Have you ever used one of those AI chatbots?
Oh, yeah, like ChatGPT or Gemini.
Right, exactly. Or Claude, you know the ones I'm talking about.
Yeah.
You sit down at your computer, you type a question into that little glowing box on your screen, and like almost instantly, it types this brilliant answer back to you.
It really does feel like magic sometimes.
It does. But when you do that, does it ever feel like the artificial intelligence is incredibly smart, but somehow totally trapped behind the glass of your screen?
Oh, I know exactly what you mean.
Like it has all this knowledge, all this raw processing power, but it's permanently locked inside a digital cage.
It is incredibly frustrating when you hit that wall. I mean, you can ask it to explain the complexities of quantum physics, right? And it gives you a perfect, easy-to-read summary.
Yeah, or you ask it to write a poem about your dog.
Exactly. A sonnet in the style of Shakespeare about your golden retriever, and it does it in 2 seconds. But then you ask it to actually do something for you in the real world.
Right, like an actual task.
Yeah, like, hey, can you actually book a flight for me? Or can you reorganize these files on my desktop? And it just gives you a list of instructions on how to do it yourself.
It's so annoying. It's like, I don't want the instructions. I want you to do it.
Right. It can't reach out. It's stuck.
It's trapped in the box. It gives you the recipe, but it refuses to bake the cake. Well, today, we are taking a deep dive into some really fascinating source material that explains the mechanics behind why that happens.
And, more importantly, how it's going to change.
Yes. We are going to explore how that exact limitation is about to disappear. Our source today explores a massive shift in technology. Basically, the idea that a large language model, which is the underlying tech behind those chatbots, is not actually a finished product.
No, by itself, it's very incomplete.
Right. So the whole mission of this deep dive is to understand a new concept called the AI agent. We're going to look at what an AI agent actually is, how it operates under the hood, and how these agents are projected to fundamentally change our world over the next 5 to 10 years.
And just to set the stage for how we're going to approach this today, we were going entirely jargon-free.
Absolutely. No complicated tech speak. The concepts in this source material are profound, but they really don't need to be buried in, Silicon Valley buzzwords.
Not at all.
We're going to use clear, simple English to break this down. Because the implications here, they affect everyone, not just programmers.
It affects every industry, every job, and every home. So to really ground this, we should probably start with a core metaphor from our source text.
The brain metaphor, right?
Exactly. The text suggests we need to stop thinking about a large language model or an LLM as a complete computer program. Instead, we need to think about it as a brain.
But just disembodied brain, like floating in a jar.
Yes,
Yeah.
A very powerful, highly educated brain, but one that is just sitting in a jar. A brain alone can't do much of anything in the physical or digital world.
Right.
So if the LLM is that brain, then the AI agent is the worker that takes commands from the brain and actually executes them.
I really want to linger on that image for a second because it perfectly sets up the rest of our discussion. The brain in the jar and the worker out in the world.
It's a great visual.
Let's break down the actual mechanics of what this AI agent is doing, starting with the brain itself.
Okay, let's look at the LLM first. As we've seen, it's undeniably powerful. The text emphasizes that this system can think, it can reason, and it can generate incredibly complex language.
Like summarizing a huge legal document.
Right. It can take a 100-page legal contract and summarize the key risks in 3 bullet points. It can translate Mandarin to Spanish flawlessly. It can even, debug complex computer code just by looking at a snippet of text.
But the limitation is always the interface. It stays inside that chat window. You ask a question, it gives an answer. It thinks deeply, but it doesn't act.
No, it doesn't.
It can't reach its hands into your email inbox, and it certainly can't reach its hands into the physical world to turn off a light switch.
And this is where the AI agent comes in to solve the problem. The source text defines an AI agent fundamentally as a bridge.
A bridge, okay.
Yeah, it's the missing link between the isolated intelligence of the brain, the LLM, and the functional reality of real-world applications.
So wait, it's not a new kind of intelligence. It's literally just a connection. It bridges the thinking part to the doing part.
That is a perfect way to look at it.
Yeah.
It goes a massive step beyond generating text. The text explains that an AI agent connects the LLM to real-time data streams, to other software programs, to live websites, and even to physical hardware, like robots.
Now, our source text uses a biological metaphor here that I want to push on a little bit.
The nervous system one.
Yeah. We established that the LLM is the brain, but then the text describes the AI agents as the capillaries and nerve endings.
Right.
Now, I get the general vibe, nerve sense signals, but let's map this out really clearly. If the AI is this brilliant brain sitting in a dark jar, what is the actual functional role of these digital nerve endings? Like, how do they change the equation?
Well, think about the human body to really grasp what the text is arguing here. Your brain is locked inside the dark, silent vault of your skull.
Yeah, it's totally sealed off.
Exactly. Your brain has no eyes.
Yeah.
It has no hands. It can't inherently feel the warmth of the sun or the cold of a glass of water.
It's just sitting in the dark, relying on incoming data.
Precisely. It relies entirely on the nervous system to feed it that data. And then, when it makes a decision, it needs nerves to send electrical signals down to your muscles.
Okay, I see where this is going.
It needs blood vessels to deliver energy to those muscles. Without that entire delivery system, the nerves and the vessels, the brain is completely powerless to affect the physical world.
Because it can't move itself.
Right. Your brain might form the thought, I am thirsty, I want to pick up that glass of water. But without the nerves firing and instructing your hand to reach out, grasp the glass, and lift it, that thought never becomes an action.
So without the agent, the ChatGPT brain is just sitting there thinking, oh, it would be great to schedule that meeting. But it has no hands to actually open the calendar app.
That's it.
The AI agent is the digital nervous system.
Exactly. But the text doesn't just leave it at a metaphor. It actually breaks down the specific mechanical steps this digital nervous system takes to execute a job.
Let's go through those.
Because this is where the illusion of magic becomes a very clear technological process.
Right.
The brain provides the cognitive power, but the agent manages the execution. The text outlines 6 distinct steps an agent goes through.
Okay, 6 steps. What's the first one?
The very first step is that the agent must understand a goal.
Understand a goal. Okay, so I'm not just treating it like a search engine anymore. I don't just type, what is the capital of France?
You give it a directive, an objective, like I need to plan a quarterly review meeting with my team.
Got it. So I give it a goal, and then what?
Well, the agent takes that objective, plan a meeting, and feeds it to the brain, the LLM, to unpack what that actually entails. Once the brain understands the context, the agent moves to the second step, which is it must make a plan.
It makes a plan. It breaks the abstract goal down into concrete steps.
Exactly. It has to think sequentially.
So the plan might be, step 1, figure out who is on the team. Step 2, check everyone's availability for next week. Step 3, find an overlapping hour. Step 4, draft an invite.
Spot on. It's doing the logistical reasoning that a human assistant would do. Now comes the third step, and this is where it completely breaks free from the chat box.
Okay, this is the exciting part.
The agent must use tools. A standard LLM cannot use tools, but an agent is programmed to reach out. It can securely connect to your calendar application. It can connect to your email server.
Wait, I want to make sure I'm wrapping my head around this simply. It's using another piece of software as a literal tool, the same way a carpenter uses a hammer.
That is the perfect way to visualize it.
So the email program is just a tool the agent picks up to get the job done.
Yes. The software is the hammer. Then we hit step 4, which naturally follows. It must take actions.
Right. It swings the hammer.
Exactly. It doesn't just draft the text of the email and show it to you. It actually triggers the software to send it. It clicks the digital buttons. It locks the time slot in the calendar.
It's moving its digital hands.
It is. But it doesn't stop there.
Mm.
Step 5 is critical for making this reliable. The agent must check results.
Check results, because things go wrong.
Right. It doesn't just throw the action out into the void and hope it worked. It verifies. Did the email bounce back? Did the calendar system throw an error saying the room is already booked? The agent reviews the environment to ensure the action actually succeeded.
And if it failed, I assume it loops back and makes a new plan.
Exactly. It acts, checks, and adjusts.
Wow.
And finally, if the check comes back positive, it reaches step 6. It can complete tasks. The goal is achieved, and it reports back to you that the meeting is set.
I mean, that is a wildly different experience than using a standard chatbot.
It really is.
It's an entire life cycle of work. Understand a goal, make a plan, use tools, take actions, check results, complete tasks.
It's the full workflow.
The brain is doing the heavy cognitive lifting, but without those digital nerves and muscles, it's totally paralyzed. The agent is what allows it to navigate the world.
And that's why the source material emphasizes that the LLM is really just the beginning. The AI agent brings the intelligence out of the theoretical realm and into practical reality.
Okay, so if we accept that this agent acts as the body connecting the brain to the world, I want to look at what these digital hands are actually doing day to day.
Let's do it.
Because our source text provides a very concrete action list. It shows us how this theoretical intelligence is being applied right now. Let's dig into these specific examples because they range from the mundane to the mind-bending.
Yeah, the text gives us 10 distinct examples of what an AI agent might be tasked with. Let's group them up to understand the progression.
Sounds
The first few are basically about personal digital assistants. Number 1 is reading emails.
Now, to be clear, we aren't talking about me copying a long email, pasting it into ChatGPT, and asking for a summary.
Right, no. We're talking about an agent that lives in your inbox, reading them natively as they arrive.
Okay, so it has persistent access.
Yes, it reads, it interprets the urgency, and it understands the context based on your past conversations.
That's huge.
And number 2 follows naturally checking a calendar. It has real-time visibility into your schedule, knowing not just when you were booked, but perhaps knowing your preference for, say, not having meetings before 9 a.m.
Right, it knows your habits.
And number 3 is booking an appointment. It takes the action to reserve the time, send the invite, and update your status.
So those first 3, reading emails, checking calendars, booking appointments, that's essentially replicating a human executive assistant.
Precisely. It's managing the flow of your digital life.
Okay, what's next?
Then the text moves into more specialized cognitive tasks. Number 4 is analyzing a spreadsheet.
I hate spreadsheets.
Most people do. But the agent doesn't just see numbers. It can look at massive data sets, identify trends, spot anomalies in a budget, and actually understand the business logic behind the rows and columns.
That's incredible.
Number 5 is writing code. It can act as a junior developer, writing scripts to automate processes or building basic web structures.
Then number 6.
Number 6 is searching documents.
Again, searching documents doesn't mean hitting CTRLF for a keyword, right?
No, it's much deeper.
It means I can say, find the clause in our vendor contracts where we are liable for shipping delays, and it actually reads through thousands of PDFs to find the semantic meaning of my request.
Exactly. It's searching by meaning, not just by matching text. Which leads to number 7, generating a report.
Putting it all together.
Right. It can take the financial anomalies it found in the spreadsheet, combine them with the liability clauses it found in the documents, and synthesize a cohesive professional summary. And number 8 is sending a message. It takes that report and securely routes it to the relevant stakeholders through Slack or email.
Okay, so up to this point, numbers 1 through 8, I am fully with you.
It makes sense, right?
It makes total sense. It's highly advanced, but it all makes logical sense because it all happens inside the computer. Searching digital documents, sending digital messages, analyzing digital spreadsheets, it's moving pixels around.
Right. It's all digital.
But the text's final 2 examples feel like a massive leap. Number 9 is controlling a robot, and number 10 is monitoring a machine.
This is where it gets real.
I really have to push back here. How on earth does a system that's fundamentally designed to predict the next word in a sentence bridge the gap to manipulating physical metal and plastic in the real world?
It's the most important hurdle to overcome if we want to understand the true impact of this technology.
I just don't see the connection yet.
To grasp how text generation turns into physical action, we have to deeply explore a concept the text leans on heavily. The concept of the workflow.
Workflow. It's a word you hear thrown around in corporate meetings all the time, but what does it actually mean in the context of an AI agent?
In this context, a workflow is the specific engineered pathway that translates a digital decision into a physical consequence.
Okay.
It's the chain of events. Let's create a highly detailed scenario to make this concrete. Let's imagine a modern manufacturing facility.
Okay, I'm with you.
On the factory floor, there's a massive, heavy-duty machine that stamps out aluminum parts for cars.
I'm picturing a loud, dangerous piece of industrial equipment.
Yeah.
Sparks flying, heavy metal moving.
Perfect. Now, modern machines like this are covered in digital sensors. They measure vibration, speed, pressure, and temperature.
Right.
Let's focus on a temperature sensor attached to the main motor. This sensor's only job is to constantly record how hot the motor is running.
Because if it gets too hot.
If the motor gets too hot, it will seize up, break, and shut down the entire production line for days. This constant data collection is the very first step of the workflow.
Got it. So the physical reality, the heat is converted into digital data by the sensor.
Yes. Now, in the past, that data might just go to a dashboard where a human operator occasionally looks at it.
Yeah.
But in the AI agent era, the agent is directly plugged into that sensor's data stream
It's watching the numbers.
constantly. The agent is receiving the signal. Temperature is 150 degrees, 155 degrees, 160 degrees.
The agent is the nerve ending feeling the heat.
Exactly. When the temperature spikes to, say, 180 degrees, the agent realizes this hits a critical threshold. It takes this data and sends it up to the LLM, the brain.
Okay, handing it to the brain.
The brain analyzes the situation based on all the technical manuals it has ingested. The brain deduces 180 degrees mean imminent motor failure. We must reduce the load immediately to cool it down.
So the brain has formed the thought, we need to slow this machine down, but again, the brain has no hands. It can't pull a lever on the factory floor.
Right. It formulates the plan. Reduce operating speed by 20%. Now, the agent takes over the execution. The agent reaches for a tool.
Like the hammer we talked about earlier.
Exactly. But in this case, the tool isn't an email program. The tool is the industrial control software that dictates the machine's speed.
Ah, okay. So the agent isn't magically moving the metal directly. It's talking to the software that already controls the metal.
Yes. It translates the brain's plan into the exact, rigid code that the industrial software requires.
Wow.
It sends a specific command through the system. Set variable speed drive to 80% capacity. The control software receives this digital command and physically alters the electrical current going to the motor.
And the heavy physical machine physically slows down.
That's the bridge.
That makes so much sense.
And the workflow isn't over. Remember step 5, checking results.
Right, it has to make sure it worked.
The agent doesn't just assume it worked. It immediately looks back at the temperature sensor. It waits and watches. Is the temperature dropping? 175, 178, 165.
And once it cools off.
Once it reaches a safe zone, the agent records that the intervention was successful and completes the task.
That completely clarifies it for me. The text isn't implying that the AI brain grows physical arms.
Yeah, not at all.
It's saying that because everything in our modern world, from cars to factory machines to thermostats, is already controlled by software, the AI agent simply needs to know how to talk to that software.
Exactly.
It translates human goals into digital text, translates that text into software commands, and those software commands trigger the physical hardware. It creates a seamless workflow from a thought to a physical action.
You've nailed it. It's a chain of translation. The intelligence flows through the workflow, resulting in real-world change.
Okay, so seeing this massive list of capabilities, from managing my calendar to preventing a factory meltdown, it begs a really obvious question.
What's that?
Well, if the large language models like ChatGPT are so smart, why can't I just use the standard out-of-the-box chatbot to do all this?
Yeah.
Why do we need to build all these separate, specific agents? This leads us right into the next major argument of our source text, which contrasts general LLMs with specific AI agents.
And the text makes a very firm stance here. Large language models, by their very nature, are general-purpose systems. They are trained on virtually the entire internet.
Right. They know a little bit about everything.
Exactly. They're designed to be a jack of all trades.
But isn't a jack of all trades a good thing? I mean, if I have an AI, I want it to know as much as possible, right?
It's fantastic if you are a curious user sitting at home. You can ask it for a recipe for lasagna, and then immediately ask it to explain the fall of the Roman Empire, and then ask it to help you fix a bug in your Python script.
Right, it's the ultimate trivia champion.
But the text argues that in the business world, a know-it-all is actually a liability.
A liability, how so?
Businesses don't operate on general trivia. They operate on highly specific, specialized processes. When you hire an employee for a highly technical role, you don't care if they know the history of Rome, right?
No, I care if they know how to do the job.
Exactly. You care if they understand the exact intricacies of your supply chain. The same goes for AI. The text breaks down specific industry needs to illustrate why general AI fails in specialized environments.
Let's run through those examples from the text because it really highlights the need for focus.
Okay, let's look at a hair salon. A local hair salon doesn't need an AI that can write computer code or debate philosophy.
Definitely not.
If they try to use a general LLM to manage their bookings, it might get confused, hallucinate a response, or start chatting with the customer about irrelevant topics.
Right, like discussing the weather instead of booking the haircut.
A hair salon needs an AI appointment agent. It needs a system whose only universe is haircuts, stylist schedules, pricing, and the booking calendar.
It needs intense, narrow focus. The guardrails need to be tight so it doesn't accidentally offer a customer a discount because it read a fictional story about discounts on the internet.
Exactly. What's the next example?
While the stakes get much higher with a hospital desperately needs efficiency, so they might want an AI patient support agent.
But a general LLM in a hospital setting is downright dangerous. It might offer unverified medical advice it's scraped from a random blog.
Oh, wow. Yeah, that's a huge liability.
A specialized hospital agent is constrained. It understands strict medical privacy laws. It knows the exact scheduling protocols for the MRI machines.
It's highly regulated.
Right. It knows how to route triage questions to a human nurse. It operates in a closed, safe ecosystem.
If I'm interacting with the hospital system, I want zero chance that the AI gets distracted. It needs to be an absolute specialist in healthcare logistics, nothing else.
Exactly. The text continues with other sectors. A factory needs the machine monitoring agent we just discussed. It doesn't need to know about retail.
Makes sense.
A school might deploy an AI teaching assistant agent. That agent needs to be trained on the specific curriculum of that school, adapting to a student's learning pace, not just regurgitating Wikipedia.
Right. It needs to know the actual lesson plan.
And a logistics company moving freight across the country needs an AI delivery planning agent, focused purely on weather patterns, fuel costs, and route optimization.
So the foundational intelligence of the LLM is powerful, but it's totally raw. It has to be refined into these specific agents.
Yes.
This naturally brings us to a metaphor from the text that I think captures this perfectly. It's the iron metaphor.
It's one of the most striking comparisons in the source material. How did you interpret the text's description of the iron?
Well, the text suggests that we should look at a massive, complex LLM the same way we look at a giant, heavy block of raw iron pulled from the earth.
Yeah.
Now, iron is incredibly valuable. It has immense potential. But iron all by itself is not a knife. Iron by itself is not a car chassis. Iron by itself is not a suspension bridge.
No, it's just a heavy block of raw material.
Exactly. You can't chop vegetables with a block of raw iron. It has to be heavily processed.
It has potential energy, but no practical utility in its current state.
Right. I actually want to introduce a different analogy here to run alongside the iron metaphor, just to look at it from another angle.
Sure, go for it.
I was thinking about it like this. Imagine having access to the largest library ever constructed, containing every single book, scroll, and document ever written in human history.
So that's the LLM.
Right, that's the LLM. But imagine there is no catalog system and there are no librarians.
Oh, that sounds like a nightmare.
If a local baker walks into that infinite library to find a very specific 18th century recipe for sourdough, they are going to be completely overwhelmed. They will wander the stacks forever because there's too much information.
They need a guide?
They need a highly specialized librarian who knows exactly which wing, which shelf, and which book contains the bakery knowledge. In this scenario, the AI agent is that specific librarian.
I really like that analogy. The infinite library is the raw cognitive power, but the librarian is the agent that navigates it to extract practical value.
Exactly.
And if we blend your librarian idea back with the text's iron metaphor, it clarifies the process of creation. The text asks a fundamental question. How does that heavy block of raw iron actually become a precise surgical scalpel or a massive bridge?
Well, it doesn't happen by accident. It requires processing. It requires a blacksmith or a foundry. It requires design, intense heat, cutting, and shaping.
Yes, and the text argues that the exact same intense processing must happen to the raw LLM. You don't just plug ChatGPT into a hospital and hope for the best.
No, that would be a disaster.
We shape the raw intelligence through agent design. We forge it by building those strict workflows we discussed earlier, dictating exactly how data moves.
Right.
The pathways, we temper it by providing specific tools, and crucially, we connect it using APIs.
Okay, let's pause right there. APIs. We promise zero jargon today, and API is definitely one of those acronyms people throw around to sound smart.
It really is.
Can we break down what an API is in the simplest possible terms without losing the technical truth of it?
Absolutely. Think of an API, which stands for Application Programming Interface, though the name doesn't really matter as a digital doorway between two different buildings.
A digital doorway. Okay.
Let's say your AI agent lives in Building A, and your Google Calendar lives in Building B. They are totally separate entities. Your agent can't just smash through the walls of Building B to look at your schedule.
Right, there are security walls, passwords, firewalls.
So the engineers who built Google Calendar created an API. It's a secure, heavily monitored doorway.
Okay, I can picture that.
The AI agent walks up to the doorway, presents its digital ID card, and if it's approved, the doorway allows it to pass specific information back and forth. It's an agreed-upon method for two pieces of software to talk to each other safely and securely.
That makes perfect sense. So an API is just the authorized doorway.
Exactly. So returning to the metaphor, the human developers act as the blacksmiths. They take the raw iron, the element.
Right.
They apply design, they build the workflows, they connect it through those API doorways to specific databases, and they inject it with narrow industry knowledge.
They shape it.
Through all of this forging and processing, the text states that the single LLM becomes the foundation for millions of unique, intelligent applications. The iron becomes the scalpel, the engine, the bridge.
This feels like a crucial turning point in our understanding of the source material. The text is actively warning us against a widespread misunderstanding in the public right now.
Yes, it is.
People assume that the chatbot is the final product, but the text explicitly debunks this. It states clearly, we should not say LLM equals application. That is not correct.
It's a fundamental error in thinking. If you believe the LLM is the final product, you will totally underestimate what's coming.
Right.
The text provides a much more accurate framework. It says LLMs provide intelligence. AI agents turn that intelligence into practical applications.
I want to repeat that because it is basically the thesis of everything we're discussing. LLMs provide the raw intelligence. AI agents turn that intelligence into practical applications.
Exactly.
The brain thinks, the worker builds, the iron is the material, the blacksmith forges the tool.
And this realization leads to a staggering conclusion. If these agents can take raw intelligence and forge it into specific, autonomous workers for literally every industry on Earth, from managing supply chains to monitoring patients to driving trucks, this is no longer just a cool software update.
No, this isn't like transitioning from an iPhone 14 to an iPhone 15. It's not just a better camera.
The source text argues forcefully that this represents a tectonic shift in human history. This brings us to a major historical comparison the text makes: the Third Industrial Revolution.
The word revolution gets thrown around a lot in tech. Every new app claims to be revolutionary.
Oh, absolutely.
But our source text uses the term strictly in the historical sense. It walks us through the timeline of the major industrial revolutions to prove exactly why the era of the AI agent belongs on that same list.
It does.
Let's trace that history, step by step, as the text lays it out.
The text anchors its argument by starting with the First Industrial Revolution, which kicked off a few hundred years ago. The defining technologies of this era were steam power and complex machinery.
We're talking about the transition from muscle to metal, burning coal, boiling water, creating pressurized steam to drive massive pistons.
Yes. Prior to that moment, if a human wanted to move a heavy stone or harvest a field, they were limited by the biological constraints of their own muscles, or the muscles of their horses and oxen.
Right, you could only do what the body allowed.
Work was strictly tied to biological calories. The steam engine shattered that limitation. The text states that the result of this first revolution was a massive explosion in physical productivity.
Because suddenly we weren't just relying on muscles.
Suddenly humans could build mechanized factories, haul tons of freight across continents via locomotives, and construct towering steel cities.
We outsourced physical labor to machines. We conquered biological limits.
Exactly. Then much later, we arrive at the Second Industrial Revolution. According to the text, this revolution was driven by the advent of computers, the internet, and broad information technology.
This is the revolution we've been swimming in for our entire lives, the digital age.
Yes, and notice the shift. The second revolution didn't give us stronger mechanical muscles. We already had those.
Right.
The text points out that IT and the internet vastly improved communication, data processing, and global connectivity.
It shrank the world.
Before the internet, sending a complex document to Tokyo meant putting it on an airplane. With the internet, it takes milliseconds. We could suddenly organize, store, and transmit infinite amounts of data instantaneously.
So if the first revolution conquered physical distance and strength, the second revolution conquered information and time.
Precisely. We outsourced data storage and communication to computers. Now the text introduces the Third Industrial Revolution, the AI agent era.
Okay, here we go.
And the text defines this era very specifically. It says, this third revolution will act as a grand integration. It will take the heavy machinery from the first revolution, combine it with the digital connectivity of the second revolution, and inject it with artificial intelligence.
There's a specific phrasing in the text that I want to dissect here. It says, machines give us physical power. Information technology gives us digital connection. AI agents give us intelligent action.
Intelligent action, yes.
Now, I understand physical power and I understand digital connection, but what does intelligent action actually look like on a spreadsheet? When the text talks about productivity in this new era, what is the real-world economic result of this intelligent action?
The economic result, according to the projections in the text, is that productivity may increase tremendously.
Tremendously is a strong word, but what does the data actually suggest? Are we talking about like a 10% improvement?
Far beyond that, the text gets very specific about the magnitude of this shift. It suggests that across many industries, baseline efficiency may increase several times over.
Several times over.
Imagine a logistics company that currently routes 100 delivery trucks a day using human dispatchers.
Okay.
With an AI agent instantly analyzing traffic, weather, fuel consumption, and delivery windows, that same company might be able to route 300 or 400 trucks with the same overhead.
A 300% or 400% increase in output, that's enough to completely dominate a market.
But the text goes even further. It states that in highly automated areas, places where workflows can be fully handed over to agents, productivity could increase 10 times or more.
A 10x multiplier. I really want the listener to sit with that number for a second. If you apply a 10x multiplier to an economy, the math gets staggering.
It changes everything.
A complex pharmaceutical research process that used to take 10 months might take 1 month. A financial audit that used to cost $50,000 might cost $5,000.
Exactly.
When you increase productivity by a factor of 10, you don't just speed things up. You completely rewrite the economics of how society functions. That's why it earns the title of an industrial revolution.
It radically alters the cost of intelligence and execution. However, the text is very careful to inject a note of realistic caution here.
Good, because it sounds almost too good to be true.
It makes it clear that this 10x utopia is not going to magically appear overnight.
Right, I'm not going to wake up next Tuesday and find my workflow is suddenly 10 times faster. What are the bottlenecks? Why does this take time?
The text outlines 4 massive hurdles that will take years to clear. First, there's the raw development phase. Engineers have to actually sit down and write the incredibly complex code to build these reliable agents and construct those API doorways we talked about.
That's a huge undertaking.
Second, there is testing. You can't just deploy an autonomous agent into a hospital or a power grid without years of rigorous testing to ensure it doesn't fail catastrophically.
Right. You need to know the agent won't accidentally shut off a life support machine because it misread a calendar invite.
Exactly. Third, there is investment. Building this infrastructure requires hundreds of billions of dollars in servers, energy grids, and human capital. Companies have to be willing to spend the money before they see the return.
And the fourth hurdle?
And fourth, perhaps the most complex hurdle, is regulation.
Ah, the legal framework. Governments scrambling to figure out who is responsible when an AI agent makes a mistake.
Yes. Creating the laws, the safety standards, and the ethical boundaries. All of this development, testing, investment, and regulation means the transition will be a grinding process spanning years.
It's not going to be easy.
But, as the text ultimately concludes, despite the hurdles, the direction of travel is absolute and clear.
The destination is set. And if we are heading toward a revolution that multiplies human output by 10, it forces us to look at the immediate environment around us. How will the basic, everyday digital tools we currently rely on transform?
This is one of the most practical and fascinating sections of the text. It forces us to rethink our relationship with our screens.
Okay, let's dive into that.
The text paints a vivid contrast between the past, which is largely how we operate today, and the AI agent era, regarding 3 very specific categories of tools: websites, machines, and software.
Let's look at the evolution of each. Let's start with websites. We all interact with dozens of websites every single day. Shopping sites, news sites, banking portals. How does the text say a standard website is going to change?
The text characterizes the websites of the past and present as essentially static pages of information.
Static. They're basically just glorified digital posters. You navigate to a page, you read the text, you click a link to another poster. The website just sits there waiting for you to do the work.
Exactly. The burden of navigation and discovery is entirely on you, the human. But in the AI agent era, the text envisions the website transforming into an active, intelligent assistant.
How does that shift from passive poster to active assistant actually play out when I'm, say, trying to buy something online?
Let's imagine you need to buy a specialized piece of equipment, like a high-end camping tent for an expedition. Right now, you go to a retailer's site, You use their clunky search bar, you read 20 different product descriptions, you try to cross-reference the specs, and you hope you make the right choice.
Which takes hours.
In the agent era, the text says the website will actively engage you. It will understand your underlying needs.
How so?
You'll simply tell the site, I'm going to the Rockies in November, there might be heavy snow, and I need a tent for 2 people under 5 pounds.
And it figures it out.
The website's integrated agent acts immediately. It understands the parameters, it filters the inventory, it answers your specific questions about wind resistance, it recommends the exact product, it processes your payment seamlessly, and the text notes it will even follow up automatically after the trip to ask how the gear performed.
Wow. It's the difference between wandering through a massive warehouse alone with a map versus walking in the front door and having an expert salesperson walk up to you, understand exactly what you need, fetch it from the back room, and ring you up.
Yes, the website comes alive.
It moves from a passive directory to an active concierge. Okay, let's look at the second category. Machines.
We touched on this with the factory example, but the text expands on the philosophy of it. It says that historically, a machine could only follow fixed, rigid instructions.
Right. A robotic arm on an assembly line is programmed to move exactly 14 inches to the left, close its grip, and move 14 inches to the right.
Exactly.
It will do that exact motion 10,000 times a day. And if the part it's supposed to grab falls off the belt, it will still just grab empty air and move it to the right, blindly following the code.
It has zero situational awareness. But in the AI agent era, the machine gains autonomy. The text says the machine will continuously monitor its own condition.
So it knows when it messes up.
Yes, it will detect that the part isn't there. It will report the problem up the chain. It will adjust its own workflow to wait for the next part. And remarkably, the text emphasizes that it will cooperate with other machines.
That cooperation aspect is wild. So if machine A realizes it's jamming up and working too slowly, it doesn't just break down. It actively communicates with machine B further up the line and says, hey, I'm backed up. Slow your output by 10% so I can clear this jam. They negotiate with each other to optimize the system.
Precisely. They become a collaborative, self-healing network rather than a series of dumb, isolated mechanisms.
Incredible. And the third category.
Finally, the third category the text examines is software itself.
This is the one that I think will impact the average office worker the most profoundly. The text says that in the past, software required humans to execute a task by clicking buttons step by step.
Yes. Software today is incredibly powerful, but it's entirely dependent on human piloting. You have to know where the hidden menus are. You have to know the keyboard shortcuts. You are the pilot pulling all the levers.
I was thinking about this in the context of my own daily frustrations. Think about doing your annual taxes or trying to merge a massive Excel database with a mailing list.
Oh, it's a nightmare.
It's miserable. You are clicking through 50 different drop-down menus, trying to remember the exact sequence of operations. If you miss one click, the whole thing fails. You are essentially acting as a robot serving the software.
That's a great way to put it. But according to the text, in the AI agent era, the software will understand a high-level goal and execute all those micro steps autonomously.
That is the core paradigm shift. You transition from micromanaging the software to managing the outcome.
Exactly.
So using my tax example, instead of me spending 6 hours clicking through a tax program, dragging and dropping receipts, categorizing expenses, I simply give the agent a prompt.
Right, a goal.
Here is the folder of all my PDFs and receipts for the year. Organize them by category, calculate my total deductible expenses, and fill out the draft tax forms. And the agent, possessing the knowledge of how the software works, goes in and clicks the invisible buttons 1,000 times a second to achieve the goal.
Exactly. The agent navigates the complex UI of the software so you don't have to.
That would save so much time.
The overarching theme the text is driving at here is a fundamental redefinition of our tools. The internet, our industrial machines, and our daily software applications are transforming from passive instruments waiting for our physical input into active, intelligent, digital workers that operate alongside us.
They become our colleagues,
Yeah.
which inevitably brings up the elephant in the room.
Ah, yes.
It's the most massive looming question in this entire discussion. If the websites, the machines, and the software are becoming active workers, if they are doing all the clicking, all the analyzing, and all the routing, what happens to the human workers who used to do those jobs?
It is the most vital and often the most anxiety-inducing question surrounding artificial intelligence. Our source text does not shy away from it. It dedicates a significant section to what it calls the great job shift.
Let's be completely honest with the listener. The concept of automation is terrifying for millions of people.
Of course it is.
When we hear that an AI agent can do a complex data entry task in 4 seconds that used to take a human clerk 4 hours, the immediate visceral reaction is fear about our livelihoods. Our source text provides a very unvarnished list of jobs that are highly susceptible to automation. Let's look at what the text identifies.
The text lists 10 specific occupations that are on the front lines of this automation wave. Let's categorize them to understand the pattern. The first group is primarily physical and spatial.
Okay, physical jobs.
First, taxi driving. Second, delivery. Third, warehouse work. Fourth, assembly line work in factories.
Let's unpack that first group. Taxi driving and delivery, that means autonomous vehicles driven by AI agents navigating city streets to move people and packages without a human at the wheel. Warehouse work and assembly line work, that's the advanced robotics we talked about, agents operating physical metal to sort boxes and build cars. These are jobs that rely on human spatial awareness and physical endurance.
Right. The systems are learning to navigate the physical world better than tired humans. Then we have the fifth job on the list, which bridges the gap. Customer service.
Right. Now, we've all dealt with terrible automated phone trees. Press 1 for billing. But we aren't talking about that.
No, much more advanced.
We are talking about highly articulate AI agents that can access your account, understand your frustration, issue a refund, and update your file, all through natural conversation.
That's right.
It's millions of call center jobs global.
It absolutely does. And the text continues with the final 5 jobs, which move squarely into the cognitive white-collar space.
Okay, what are they?
Sixth, simple data entry. Seventh, basic scheduling. Eighth, repetitive office work. Ninth, simple report generation. 10th, basic inspection tasks.
So entering numbers into a spreadsheet, organizing calendars, writing weekly status summaries, and checking documents for errors.
Yes.
These aren't physical jobs. These are mental jobs. But the key unifier here is that they are highly repetitive.
Exactly. The text's overarching summary is blunt. Many repetitive jobs may be automated. Whether the repetition is physical, like lifting a box, or cognitive, like copying data from one screen to another, if it follows a predictable pattern, an agent will eventually do it faster and cheaper.
I really have to pause and push back on the optimism of the text here, because we are talking about a monumental disruption. If you look at that list, from truck drivers to customer support reps to office clerks that represents tens of millions of human beings,
It does.
their paychecks rely on those repetitive tasks. If the agents swallow all of that work, we have to ask the dystopian question, does this mean a massive portion of humanity will simply become economically useless?
The text directly anticipates that exact fear.
Yes.
The central tension of the revolution. But it uses very deliberate, definitive language to offer a counter-narrative. The text explicitly states, this does not mean humans will become useless.
It's easy for a text to say that, but what is the actual mechanism for human survival if the robots are doing the work? Where do humans go?
The text argues that the nature of human work will be forced to evolve. It'll move to a higher level.
A higher level, meaning what?
The theory is that because AI releases us from the grinding burden of heavy physical labor and mind-numbing repetitive mental labor, human cognitive energy is freed up. We will shift our focus entirely away from acting like machines and shift toward the domains where machines inherently fail.
So the premise is stop competing with the machine on repetitive tasks and lean into what makes you uniquely biological and human.
Exactly.
What are the specific areas the text predicts humans will migrate toward?
The text provides a deeply humanistic list of areas where our focus will inevitably shift. Let's go through them. It says humans will focus more on art, design, communication, education, and care.
I want to stop and really examine care. This is profound.
It is.
Caring for a toddler, caring for an aging parent, caring for a patient in hospice. These tasks require profound empathy, emotional intelligence, and physical tenderness.
Something an AI just doesn't have.
Right. As advanced as an AI agent might be, it cannot genuinely empathize. A robot might be able to perfectly monitor an elderly patient's heart rate, but it cannot hold their hand and offer the genuine comfort of shared human mortality. That is a purely human domain.
Absolutely. Care is irreducible to an algorithm. The text suggests that as repetitive work vanishes, society will revalue and reallocate human energy toward these caring professions.
That's a very hopeful vision.
It is. The list continues with other deeply human pursuits. Humans will focus on entertainment, research, environmental protection, and community service.
Again, these are pursuits that require a desire to connect, to understand the unknown, and to improve the collective human condition. A robot doesn't care if the local park is polluted, humans do.
Exactly.
But what about the technology itself? Surely there are jobs related to the AI.
Yes, the text outlines 3 new areas of focus directly related to managing this new world. Humans will focus on supervising AI systems, improving robot performance, and most critically, making ethical decisions.
That's a fascinating paradigm shift. Instead of the human being the worker sweating on the assembly line, the human becomes the manager, the orchestrator.
Yes, the supervisor.
They watch over the intelligence system, tweak its parameters, and ultimately make the moral calls about what the system should and should not be allowed to do.
Exactly. The human moves from executing the labor to guiding the intelligence.
Okay. We've discussed this massive shift in abstract terms, moving from repetitive tasks to higher-level creative and caring work. But I want to ground this. I want to try and paint a picture of what this actually looks like in society on a day-to-day basis.
Sure.
Our source text provides a sector-by-sector vision of the future. It gives us tangible scenarios. Let's deliberately walk through these future scenarios from the text and visualize the world they are predicting.
Let's begin on the factory floor. The text paints a picture where the actual building of products is entirely handled by robotic systems. We've established that.
Right.
But what are the AI agents doing in the background? The text says the agents monitor the microscopic quality of every product. They analyze the vibration data to predict equipment failure weeks before it happens.
Wow.
They automatically reorder raw materials from global suppliers the second inventory drops below a threshold. They schedule the production runs based on market demand.
And in this futuristic factory, what is the human being actually doing?
The text notes that human managers will no longer walk the floor manually inspecting gauges or tightening bolts. Instead, they sit in a control center supervising the holistic intelligence system.
Like mission control.
Right? They look at macro-level trends, manage human-vendor relationships, and handle the unpredictable edge cases that the AI hasn't seen before. They orchestrate the symphony.
They manage the factory as an organism rather than working on the machines. Okay, let's step outside the factory. What does the text say about transportation?
In transportation, the text envisions a world where autonomous vehicles are the norm. Taxis, long-haul trucks, and last-mile delivery robots.
That changes our cities entirely.
Yes. The AI agents act as the central nervous system for a city's traffic grid. They plan the most efficient routes dynamically. They talk to each other to avoid congestion.
Which saves so much time.
They optimize acceleration and braking to drastically reduce fuel consumption. And they react faster than human reflexes to improve safety.
So, ideally, a world with virtually no traffic jams, massive reductions in carbon emissions from idling cars, and a plummeting accident rate because the agents are seamlessly coordinating the dance of millions of vehicles.
That's the vision.
That sounds incredible. But let's move into our private lives. What does the text say about our homes?
For the domestic sphere, the text describes the advent of family robots.
Like robotic butlers?
Sort of. These are physical agents that assist with the heavy lifting of daily life. They may help clean the physical space, cook meals, organize household logistics, and provide physical assistance to the elderly or disabled within the home.
This ties directly back to what we discussed earlier about releasing us from physical labor. If I don't have to spend 2 hours every evening cooking, doing dishes, and folding laundry, that is 2 hours of my life returned to me.
It's huge.
Humans will have more time to actually spend with their children, or read, or pursue a hobby. It's a reclamation of time. What about the healthcare sector?
In healthcare, the text sees AI agents acting as tireless administrative and diagnostic partners. Agents will help doctors manage the overwhelming flood of patient data and medical journals.
Which doctors spend way too much time doing now.
Exactly. They will monitor patients' wearable health sensors continuously, alerting the doctor only when an anomaly occurs. They can handle the logistics of reminding patients to take medications and scheduling follow-ups.
This solves one of the biggest complaints in modern medicine. Doctors today spend half their time staring at a laptop, typing notes into a clunky database.
Yes, it burns them out.
If the agent handles the data entry and the chart organization, the doctor can turn their chair around, look the patient in the eye, and spend their time actually practicing the care we talked about.
Precisely. It strips away the bureaucracy so the human can focus on the healing. Moving to education, the text suggests a revolutionary concept: AI tutors that help students learn at their own individual speed.
This could fundamentally change society. Right now, a human teacher has 30 kids in a room, They have to teach to the middle.
It's an impossible job.
It is. If a kid falls behind, they stay behind. If a kid is a genius, they get bored. But an AI tutor agent can adapt. It realizes that a student learns visually, so it generates diagrams.
Right.
It realizes they are struggling with fractions, so it spends 3 extra days on fractions with infinite patience. It's a personalized, world-class educator for every single child, regardless of income.
Yes. It democratizes elite, personalized education. Finally, the text looks at government and public service.
What do agents do there?
It envisions AI agents helping city planners manage municipal resources, monitoring environmental data to predict floods or pollution spikes, and drastically improving the efficiency of city services like waste management and grid distribution.
Organizing a civilization's resources intelligently. When I look at all these sectors collectively, the factories, the transportation grids, our homes, our hospitals, our schools, I'm sensing a massive underlying economic implication.
Oh, definitely.
The text argues that if productivity increases by a factor of 10 across all these domains because of AI agents, society itself will fundamentally change.
Yes. The text makes a bold economic assertion. It says that because production becomes so incredibly efficient, society may become drastically richer in basic products and services.
It claims that food, housing, basic goods, and daily energy will become significantly easier and cheaper to provide.
That is the logical outcome of a 10x productivity revolution.
This leads me to a deeply philosophical question, one that is actually raised by the source text.
Okay, let's hear it.
If everything from the food we eat to the houses we live in becomes radically easier to produce because intelligent machines are doing the heavy lifting, does this mean we might eventually reach a point where humans do not have to work purely for basic survival?
The text embraces this highly optimistic, almost utopian vision. It states it plainly. In the future, humans may not only work for survival.
Wow.
It suggests that the crushing anxiety of securing basic necessities could be alleviated for a large portion of humanity.
Because the baseline of survival, caloric intake, shelter, warmth, is being handled by the automated infrastructure.
Yes. And because people will be freed from the daily grind of working just to survive, the text predicts a renaissance of human potential.
A renaissance?
People will have the freedom to develop their latent talents. They will have the time to create art, to explore science, to care deeply for their communities, and to focus on self-actualization rather than mere existence.
It sounds beautiful, a world where machines do the toil and humans get to focus purely on the joy and meaning of being human. It's the ultimate promise of technology.
Yeah.
But, and I know there's a massive but looming over this entire conversation.
There is an incredibly important but. The text does not end on a note of blind optimism. It issues a very stark, clear warning.
What's the warning?
It says this utopian vision is possible, but we need to be extremely careful. The future is not automatic.
The future is not automatic. We don't just sit back and watch it happen. We have to steer it. We have to design the guardrails.
Exactly.
This brings us to the final and arguably most important major section of our source text: human responsibility.
This is the critical pivot of the entire deep dive. The transition into this automated, agent-driven world brings with it unprecedented ethical responsibilities.
Right.
The text insists that we must actively design a controllable future, otherwise the systems could optimize for the wrong things.
Let's get specific about these guardrails.
Yeah.
What are the non-negotiable rules the text says we must embed into these agents?
The text lays out 5 categorical demands for the design of AI systems. First, AI agents must be fundamentally safe. They cannot cause physical or digital harm.
That's step 1. What's next?
Second, AI agents must be controllable. Humans must always have the ability to override or shut down a system.
An off switch, essential.
Third, AI agents must protect privacy. They will have access to our intimate data, and that cannot be exploited. Fourth, AI agents must be fair. They cannot encode biases that discriminate against certain groups of people.
And the 5th demand.
The 5th is the overarching philosophy. AI agents must serve people, not control people.
Serve people, not control people. That is the golden rule of the agent era. But an AI, no matter how intelligent, cannot invent these moral rules for itself. It only knows what it is programmed to optimize.
Exactly. This is the crux of human responsibility. The text is definitive about the human role in the loop.
We have to step up.
We are required to set the high-level goals. We are required to audit and check the results to ensure they align with human values. We are needed to draft the laws and regulations. We are the moral compass, ensuring the systems don't inadvertently harm society in the pursuit of efficiency.
We have to decide what kind of society we actually want to live in. The text introduces a corporate concept here to explain this. It talks about designing better KPIs.
Right, KPIs.
Before we get into the specifics, can you define what a KPI is in this context?
KPI stands for Key Performance Indicator. It's a metric used to measure if a system or a business is successful.
Okay, an example.
In the first industrial revolution, a factory's KPI was brutally simple. Produce 100 plastic cups every hour at the lowest possible cost. If the factory did that, it was considered successful, even if it dumped toxic sludge into the river to achieve it.
Wow. Okay, so the KPI was purely about output.
Right. But the text argues that in the era of highly intelligent autonomous agents, those old, brutal KPIs are dangerous.
Because the AI is too smart.
If you tell an AI agent to maximize profit at all costs, it might do things that are technically legal but socially destructive.
Exactly. And so the text says we need vastly better, more holistic KPIs to judge our AI systems. It lists 6 critical new questions, new metrics of success that humans must constantly ask when deploying these agents.
Let's walk through those 6 questions from the text because they represent a total shift in how we view technology.
Let's do it. What's the first one?
First, is the robot or agent actually helping people?
Okay, basic utility.
Second, is the AI agent saving energy and resources, or is it wasteful?
Efficiency.
Third, is the system fair and equitable to everyone it interacts with? Fourth, is it demonstrably safe?
Or fairness and safety. Got it.
Fifth, is its operation good for the broader environment? And sixth, is it genuinely improving human life?
I really want to linger on that last one. Is it improving human life? We aren't just asking, is the software faster, or did it reduce payroll costs by 20%?
No, it's a much deeper question.
Yeah. We are demanding a much higher standard. We are asking if the deployment of this intelligence actually enriches the human experience.
Yes, it elevates the measurement of success from pure economics to human well-being. And because we are forced to ask these incredibly deep philosophical questions about what constitutes a good life, the text makes a powerful concluding statement.
What's that?
It argues that the AI agent era is not merely a technological revolution.
It's far bigger than that.
Yes. The text declares it to be a social revolution.
A social revolution.
Yeah.
Because it touches the very fabric of how we organize our time on this planet.
It forces us to completely rethink the foundations of society. We have to rethink the definition of work. We have to rethink our educational models to prepare children for a world of agents.
Right.
We have to rethink how we distribute the wealth generated by massive productivity, ensuring fairness. And ultimately, it forces us to rethink the very meaning of human life when our primary function is no longer manual or repetitive labor.
When the machines can do the heavy lifting, both physically and mentally, we are left staring at ourselves, forced to ask, what are we actually here to do?
It's a huge question.
What makes us uniquely human when intelligence is commodified? That is a staggering philosophical shift, and it's being driven entirely by lines of code.
It is a profound inflection point, and the text leaves the responsibility firmly in our hands. The AI agents will tirelessly follow the workflows and goals we set for them. It is entirely up to us to lead them well.
Okay, we have covered an incredible amount of conceptual ground today. Let's take a moment to summarize the core takeaways from our deep dive into the source material, keeping true to the clear conceptual framework we established.
The foundational concept begins with the brain. A large language model like ChatGPT acts as a brilliant reasoning brain. But on its own, it is a general intelligence trapped inside a digital jar, unable to affect the world.
Then we introduce the AI agent. The agent is the digital worker. It provides the nervous system, the hands, and the workflows. It takes the abstract thoughts of the LLM, connects them through API doorways to tools and software, and executes real-world actions.
We explored the metaphor of raw iron. Just as a heavy block of iron must be intensely forged and processed to become a precise surgical tool, the general intelligence of an LLM must be processed through strict agent design to become a safe, specialized application.
A highly focused agent for managing a hospital's triage, a specialized agent monitoring the heat sensors on a factory floor, a dedicated tutor agent adapting to a child's learning speed.
And as millions of these specialized intelligent applications are embedded into our websites, our machines, and our software, the text argues it will trigger a third industrial revolution, multiplying human productivity by a factor of 10.
But with that massive economic shift comes the great job shift. Millions of repetitive physical and cognitive tasks will be automated. However, the text's ultimate hopeful vision is that this will release humanity from the burden of grinding labor.
It frees us to elevate our focus toward uniquely human endeavors. Art, design, complex problem solving, and most importantly, deep empathetic care for one another.
But we only achieve that utopian vision if we take human responsibility seriously. We must design these systems to be safe, fair, and controllable. We must ensure that KPIs measure human flourishing, not just corporate efficiency.
Because ultimately, this isn't just about faster software. It's a social revolution that forces us to redefine what a meaningful human life looks like.
This has been a truly mind-expanding journey through the source text. To close out our deep dive today, I want to leave you, the listener, with a final provocative thought.
Something to chew on.
Exactly. This is a mental exercise based directly on the final human-centric message of our source text. I want you to actively think about this as you go about the rest of your day.
Okay.
Look closely at your own daily life right now. Think about your job, your chores at home, your logistical responsibilities. What is the heavy, repetitive mental or physical labor that you dread doing every single day?
We all have something.
Maybe it's answering the same endless types of emails. Maybe it's the frustration of organizing complex spreadsheets for your boss. Maybe it's the exhaustion of trying to coordinate schedules between your family and your work.
It can be so draining.
Imagine for just a moment that a highly capable AI agent could act as your personal digital hands. Imagine you could hand that specific, draining, repetitive task over to an agent and trust that it would be handled perfectly every single time.
Just taken off your plate.
If that massive burden of time and mental energy was suddenly lifted from your shoulders, what higher-level human talent would you pursue?
A beautiful question.
Whether it's painting or spending more time caring for your family or volunteering in your community or simply learning a completely new skill, what part of your humanity would you finally have the freedom to develop?
It's the most vital question we can ask ourselves right now. How can we intentionally use these new AI agents to build a more meaningful world, starting with the reclamation of our own time?
Thank you so much for joining us for this deep dive. Keep learning, keep asking the hard questions, and keep thinking carefully about the future we are all building together.